In UniFi Protect application, if you go to Settings, Control Plane, Integrations, you can see your UniFi console support Protect API. So you can have some custom interaction from outside with the UniFi application. And at the same time, if you go to Alarm Manager for any given trigger, you can enable a thing so-called Webhook. The webhook and the API, they are all related to how to enhance, enrich the UniFi Protect experience. So you can do something custom. In this video, let's use a very simple example to integrate these two things together to interact with UniFi Protect. In my lab environment, I use a UDM Pro. It runs both network application and Protect application. So within Protect, I have just one camera, a G5 Flex, and a UniFi Protect sensor. What I want to achieve in this video is if the camera detects any motion, it will trigger my custom application, and my application will go to the Protect, grab several snapshots so that from outside of the UniFi application, we can have something documented and I can see what's going on once the event happens. First, let's talk about API. In the past, I had a video about UniFi Network Application API. In that video, I discussed how to use Postman to test the API. But keep in mind, for the free version, it's only good for testing. You cannot really run your application. But don't worry about it, because to write a custom application, to run a server, to call the API is very easy if you use the proper tools. So in this video, I'm not going to use Postman anymore. I'm simply using a programming tool to directly do coding. Okay, in this video, I'm going to use Microsoft VS Code as the development environment and Python as the programming language, because it's very easy to program and understand and run. So let me show you the skeleton of the program. Let me explain the simple coding here. So this line, I will get the IP address for the UniFi Protect console. So I don't want to hard code it in the code. I decide to get it from the operating system's environment variable. I should have a variable called this name. Of course, to make it work, we need to maintain the variable from the OS level somehow. This environment is Mac OS, so I need to go to the operating system. So in the lower part of the screen, let me cd to my home page. Okay, let me edit the profile file. Because this is Mac OS, by default, I use the Z shell. So the profile is under the name .z profile. Of course, there are a lot of existing code there, but what I need for this particular code is this line. So I will export a variable. It's called console IP with this value. This is my lab environment UDM Pro's IP address, because I run the UniFi Protect application on the same UDM Pro. And then I need to get the API key. API key is very simple for your application to get authenticated into the UniFi console. In the UniFi Protect application, if you go to Settings, Control Plane, under Integrations, by default, you do not have an API key. You need to generate it. So let me give it whatever random name. Then I say create a API key. Here I need to copy the key. You will only see the key once. So before close it, make sure you copy it. Okay. Now I have a key existing, so any application can use that key to be authenticated into UniFi Protect. Then in the same Z profile file, I need to paste the key I just copied. Okay, then end editing. I have the environment variable updated, but to make my change work, I need to quit this application and launch it again. We are not done with this line yet. We just got the API key from the environment variable, right? Later, the key will be used in every single API call. I need to prepare a HTTP request header. So in the header, the only absolutely necessary value I need is with this key name. It's called x-api-key, and with the value we can get from the environment variable. So in this way, I construct a header so that I can use it in every single API call. And then here in this line, I will prepare a server. The server is Flask server. Flask is a micro web framework for Python. It is designed for building web applications and APIs with simplicity and flexibility. In this video, just by using Flask, we can simply build a server. This line, we indicate a endpoint, a URL. I can use this service provided under this URL to provide service so that later the UniFi Protect can call this service. Later you will see how this one is used. And then here, this define, it will define the API call itself for the webhook. By the way, don't be confused about the term API here. In this video, I use API in two different contexts. One is the API calls supported by UniFi Protect. The other one is our custom application. Basically, UniFi Protect will call our custom API through Webhook. But inside our custom API, we will call Protect's standard API. They are both APIs, but one provided by Protect, the other one provided by our custom coding. Okay, it will simply get the data and then print the data. At the end, it will return a success code so that UniFi Protect will know the webhook call is successful. Then we will simply run this web server. If I do not have this host equals to 0000, the web server will only bind to the local host. It won't bind to the real IP, so the server cannot be called from outside. To avoid that, I specify the host equals to R0. This application will bind to whatever IP addresses this local machine has. Okay, and then of course the second parameter, I specify a custom part. So in this way, I run the application server. Now we have the program, but in UniFi Protect, we haven't done anything so that the UniFi Protect can call our server. Webhook is a method of augmenting or altering the behavior of a web application with custom callbacks. Here in the context of this video, the web application is the UniFi Protect. The callback is the API provided by our custom application server. And the purpose we implement the webhook is to enhance the feature of the UniFi Protect because it doesn't do what we want, so we want to implement the logic in a custom application. The webhook is just a way for the existing UniFi Protect to call our functionality. If we go to Alarm Manager for any given trigger, in this video, I'm going to use motion as an example. This is motion. Click on it, then click on the Edit Alarm. So you can see this is the screen to configure trigger, scope, and action. For trigger, here we are talking about a type of activity, which is motion. Then for scope, because in this environment, I only have one testing camera, it's G5 flags. That's the scope. Then for action, what we want to achieve is to enable webhook. And here it has a drop down about two different types of webhook. For this video, we want to choose the custom webhook. Then here I need to provide a URL. So the URL is the callback, is the hook. The URL should be supported by my custom application. How do I even get the URL? It's very easy. You don't need to guess. So here you have the application, right? You simply run it. See here in the console, you get the beginning part of the URL. Let me copy it, then paste in the UniFi Protect. But we are not done yet because this is just the URL for the custom application. Here it is talking about a particular hook for this trigger. So if we examine the code here, we did specify this webhook, right? So we need to append that part to the delivery URL. Then we get the complete URL. It is the endpoint for our custom API server for our custom web application. Okay, if you check the coding again, see here we see method equals to post. That's what I want in the custom coding, but by default the webhook will be called in a get method. To change that, we need to select the advanced setting and change the method from get to post. That's it. We are done with the webhook customizing in UniFi Protect. So let me save it. You know what? Now we have everything ready. We have webhook configured in UniFi Protect. We have our custom application running. Now let me simulate some motions near the camera. Let's see what will happen. You can see something happened. It did what I wanted to do. It simply dumped the JSON content of the request called from UniFi Protect. You can see the JSON. It simply provides the detailed information about this alarm. It's a motion and the timestamp. If you want, you can go to the UniFi Protect for more details, right? Okay, perfect. That means our skeleton, the framework of our application works. We can continue to add more logics, to add more meat so that it can behave like a real-world application. Let's continue. See this diagram? What we just accomplished is, okay, we have some motion. The camera captured it. The event happens. Then the UniFi Protect will fire the trigger. The trigger is about motion, right? Then the alarm manager is already configured to take action. The action is webhook. So the UniFi Protect will call the webhook, basically a HTTP request. It will send to my custom application. My custom application is what I need to do to automate the reaction. So currently my custom code doesn't really do anything, so I want to enrich it. In the second iteration, what I want to do is to call the API provided by UniFi console, the UniFi Protect, so that I can take a camera snapshot after the event happens. Okay, so let's see how we can do that. In the UniFi Protect API documentation for camera information and management, you can see it does support a API to get camera snapshot. Then if you check the specification for this API, it needs the camera ID. To implement the logic, we need to find out the ID for this particular camera. I need to have some utility, a helper program, find it out. So this is what this helper program for. In this helper program, I need to really call some API to get some IDs so that we can use in our real custom application. That's why I call this program a helper program. Just one note here, because we are calling the UniFi Protect API, the UniFi Protect has a self-signed certificate. If you simply use your own code to call the API, you will receive a warning regarding the certificate. Just to avoid that annoying warning, so I have this line. It's not really necessary, but I simply want to disable the warning. Then in the same way, from the environment variable, I get the IP address for UniFi Protect, got the API key from the environment variable, and in the same way, I construct the header with the API key, right? And then here, I'm really getting ready to to call our very first API. So what I want to call is to get all the cameras. In the right side, in the API document, you can see the specification for get all cameras. You can see the URL is very simple and you don't need to provide any parameter. This is what we are going to do. I need to construct the URL by using the dynamic IP address. Here, I really start calling the UniFi Protect using the URL, provide the headers we just prepared. In this way, I got the response back. And in the right side, you can see a example return, right? It's just a JSON array format, and each element is a camera. What I'm doing is I want to get the JSON data, then got the very first element because I know in my testing environment, I only have one camera. So that's why I can hard code the very first element and then I get the ID field. In this way, I can get the camera ID. Keep in mind, this is just a helper program, right? I use it to assist my code writing. It's not the final code for the custom application. That's why I have the luxury to use whatever hard coding I want. Next, in this iteration, we are not really using this information, but I have this line of code anyway, because in the third iteration, I'm going to use the sensor to do something. So I will get the camera ID and the sensor ID. This is the simple helper program. Let me run it. Yeah, see, very fast. It got successful, and I copy the first ID, which is for the camera. Go to a terminal, edit zip file for camera ID. Let me add a new environment variable, paste the value, then go back, copy the second ID, which is for sensor. Add another variable for sensor ID, paste the value. Okay, save it. The environment variables are updated in zip file. To make it effective, I need to relaunch the Microsoft code. We are done with this helper program. Close it. Now we can work on our second iteration, this v1 Python file. The beginning part of the program is the same as previous version. I don't need to talk about them again. Let's look into the webhook definition. So remember in our previous iteration, when the UniFi Protect called this webhook, we simply print out the JSON content just to showcase, okay, this webhook is called, right? But this time, we really want to do something. From the alarm JSON information, I will get the name and make sure only if the name is motion, I will do something. In the early part, I constructed this URL. So this URL is to get the camera snapshot. In the right side, API document for camera information, you can see this API call, get camera snapshot. It will return the image in JPEG format, and you need to provide a path parameter, which means the ID should be part of the URL. That's why in the left side, this is how I construct the URL. The beginning part is very easy to understand, and then I concatenate the variable ID, which I got from the environment variable, then call the snapshot API. That's it. In this way, by using this line of code, I will get the response back. The response contains the image, the snapshot. So then I will check if the response status is successful. I will construct a dynamic name for the image file. In the left side, the folder structure, you can see I already pre-created a snapshot folder under my home folder. Then I will use the timestamp to construct a dynamic file name. Then I will use this open function to create a new file. The parameter means write binary. Then I will write what? I will write the response content. Why in this way I will get the image? In the right side, in the response, you can see the response schema is image JPEG. So the whole response is the JPEG itself. That's why I simply write the content to a file. That's it. That's my JPEG file. That's how easy it is for this second iteration of custom application. I simply add some real action. I will go back to the API server to get a snapshot. So before I run it, let's use this diagram to understand what really happened. In this very simple scenario, we have two API servers. One, our custom application, because we have a webhook. The webhook itself, in fact, is also an API. UniFi Protect will call our custom API, this green one. At the same time, UniFi Protect itself provides some standard APIs, and the snapshot is one of them, right? So the flow is the UniFi Protect will call our webhook. Our webhook will go back, call UniFi Protect, call some other APIs. So that's why you see these interactions here. Okay, just want to make it clear. Now we are ready to run it. Let me run the program. Okay, it's ready to be called. Now let me go to the camera to simulate some motion. Let's see whether we can get any snapshot back. Okay, you can see something displayed in the console, but what I'm really interested in is the snapshot folder. You can see there's an image generated and our Yoda is coming. That's the motion. Okay, it's a success. So we successfully captured a snapshot after the event happens. Now let's move on to the very last iteration for this video. In the third iteration, I simply want to enhance the previous iteration's functionality. I will make two changes. First, instead of just taking one snapshot, I want to take 5. The second change is at the same time, I also want to get some additional information from the sensor so that I can get the temperature, the wind speed, motion speed, a lot of useful information, which later may help me to understand what motion happens. Let's directly jump to the webhook definition. Once I got the event, if it's motion, I will have a while loop 5 times. I will take 5 snapshots. After taking each snapshot, I will let the program sleep for 1 second, which means I will take 5 snapshots for the 5 seconds after the event. And after each snapshot, I will also request additional information. It's about sensor. In the right side, if we go to the sensor related API here, you can see I have the get sensor details API call. So in the similar way, in the pass parameters, I need to provide the sensor ID. Then here from the example, you can see what type of information can be provided from sensor in JSON format. Of course, in real-world application, you want to save the information to your database, right? But for this example application, I will simply dump the JSON information into file. So that's why here I simply dump the response to a text format file. That's it. Okay. If a motion event happens, I will expect 5 snapshot JPEG files and 5 statistics files for sensor. Let's see whether I can get the information I need. So let me run the program, then go to the camera to simulate a motion. Okay, something happened. Then in snapshot folder, we have 5 new files. Under sensor folder, I have 5 new files. Let's check the captured snapshot. The first image. They are identical. So here is the problem of the current API offers from UniFi Protect. It only provides the get snapshot API without a timestamp as parameter, which means you can only get the current snapshot. But what we really want to do for this custom application is we want to get the snapshots during the motion, right? Apparently, based on the current API call, we cannot achieve that. I can understand why there's no API call to get the history, because maybe Ubiquiti want to avoid the API call to be abused. You can think of the system resource needed just to support many API calls to get historical videos or snapshots, right? And of course, another reason is based on your configuration, your camera may not have the 24/7 video open at all, right? It's very possible you have no way to get history. So because of different reasons, there's no API call for now to get the history. But at least we validated the idea works. In the future, I hope Ubiquiti can provide some way to get the historical snapshots. Then for the sensor statistics, let me open example one. Yeah, you can see this is the beautified JSON format. We can have humidity, light, temperature, a lot of useful information. Of course, in this example, for most of the information, there is no real value because I simply haven't enabled those monitoring yet. This ends the video. Thanks for watching.